Good morning, everyone. Thanks for joining this talk. We're going to talk about the awesome future of web apps. And my name is Jad Joubran. I'm a full-stack teacher and technical consultant. So we're going to talk about the awesome future of web apps. And although this is not a progressive web apps talk, this involves a little bit of progressive web apps. So I'm going to start by having a refresher for progressive web apps, making sure we're all on the same page. And then I'm going to talk about modern best practices for web apps. And finally, I'm going to conclude with upcoming web APIs. So let's start with the PWA Refresher. Has anyone built any PWA lately? OK, great. So I think progressive web apps are an ongoing solution to solve the pain points for the mobile web, for the web and especially the mobile web. Because the mobile web is very slow, and we aim to solve these problems. We aim to make it faster, more engaging, with progressive web apps. So your users can add a PWA to their home screen by clicking on the overflow menu and add to home screen. And once they do that, they'll have an icon on the home screen. And if they click on it, they will have an immersive experience. All of this is possible because of the web app manifest, which is a JSON file where you define key value pairs for the browser to understand more about your progressive web app. And the most important keyword of these is display standalone, which hides the browser UI and allows you to have this immersive experience. Another key aspect of progressive web apps is service worker. Traditionally, if you have a page, it sends a request that goes to the network, and then you get back the response. But once you have a service worker installed, this acts like a proxy and intercepts every request that goes from your web page to the internet. This allows us to do a lot of powerful things that we would never thought we would be able to do on the web before. Because we can intercept network requests, we can make our apps work offline. They can receive push notifications, and you can also do background sync. So how do we register a service worker? First of all, you want to make sure there's support for it, and then you use the register method on navigator.serviceworker. And this is a promise, so you can make sure if it worked or if there was any error. Now, how do you write the service worker code? There are multiple ways. You could use Google Chrome SW Precache, which is a node module that generates service worker code based on a configuration file. So you could say, for example, I want to make, as part of my precache, index.html and all the images in the image folder precached. So these are the assets that will be available to your users as soon as the service worker is installed. And then you simply run this script, pass in the configuration file, and you will have the service worker JavaScript file. So after doing that, after installing the service worker, we'll be able to have this kind of model. We have a service worker that intercepts the network requests, and we can decide to completely bypass the network because we have those resources in the cache. And what this allows us to do, instead of going to the network and waiting for these requests, we can consistently and reliably serve them from the cache. And that's a great win because for those important resources, even if we don't have internet, even if we're on a flaky internet connection, we can always consistently serve them to the user. And then the other part of this is using SW Toolbox, which gives us dynamic caching strategies. So you can decide if you're talking with an API, let's say you're talking with your own API, you could choose to use one of the following three strategies. The first one is cache first, which means as soon as something is in the cache, I will keep on using it from the cache, completely bypassing the network. Another one is network first, which means let's go to the network, let's try to get it from the network. In case it fails, we'll just revert back to the cache. So this is like a fallback mechanism to the cache. And the third one is fastest. We'll race both the network and the cache, and most probably the network is going to resolve the cache is going to resolve first. And by the time the request from the network resolves, we're going to update the cache for the next time we use it. So it's like, let's grab something from the cache, and let's keep an updated copy in the cache as well. That's coming from the network. So, and we typically use both SW precache and SW toolbox together in the same configuration file by passing a runtime caching object. So you could say for this pattern, whenever I go to the API/countries, I'm going to use the cache first handler. And if you're doing service workers lately, there's a new library called Workbox. There's nothing wrong with SW toolbox or SW precache. They're being used in production a lot. But there's just a newer library called Workbox, which combines both SW Toolbox and SW Precache. You could use whichever one you'd like. This one is more modular. That's the only thing that's different. It focuses more on modularity. What about browser support? Well, I actually have good news. So it's shipped on Chrome, Firefox, Opera, Samsung Internet. And by the way, if you have an Android and you have Samsung Internet, if you add an app to the home screen from Samsung Internet and from Chrome, you cannot tell the difference. That's the nice thing about web standards. And Edge is in development. It's been a couple of months already, and Safari, the great news, is in development for approximately 2 weeks now. So that's amazing news. So all we know for Safari right now is that they're working on the service worker spec. So there's also a fallback you can do for iOS. You could add some proprietary meta tags, like the mobile web app title. This is similar to the manifest title. And you could also do the full screen experience, but I would say make sure to try this before. Because if you make your app full screen and you don't test on iOS, there's a high possibility your users will be stuck there forever because they don't have a back button. So you have to make sure to test. Also, some users have reported performance issues. It doesn't always happen. So if you want to use those two, just make sure to try it. And this allows you to override the theme color. So that was the PWA Refresher. If you've got any questions about progressive web apps, I can answer them towards the end. Now, let's talk more about modern best practices. And in those best practices, you may see me talk sometimes about progressive web apps. Don't forget, because progressive web apps are indeed the future of the web. Even if you don't use them, they are pushing towards best practices. So you can extract a lot of best practices from progressive web apps. So the first modern best practice is to use the theme color. And the theme color allows you in Chrome or in the browser to theme the URL bar, to change the theme. And to do that, this is completely independent from the manifest.json. If you want to do that, you have to have a meta tag called theme color, which lets you override the theme color. Now, if you had a progressive web app, I would use the same value here as the one that I would have in the manifest.json. The next important piece is to optimize the first paint. The problem with the web is most users are used to click a link and then see a white screen for 5 seconds, and then see the logo, and then wait for 10 seconds. So we want to solve this. We want to optimize the first paint. We want to have something on the screen in less than 300 milliseconds. And to do that in 2017, I would recommend that you inline the most important piece of your CSS in the head. So try to go through your CSS. There are automated ways, like critical CSS node module, or you could also do it manually and get the most important chunk of CSS and inline it in the head. It shouldn't exceed probably 100 or 150 kilobytes. And then for the rest of your CSS, we want to load it in a way that doesn't block. And this was a common challenge, but there's a new way to do it in 2017. So if you want to asynchronously load the rest of the CSS without blocking, you want to preload it. And to preload it, you use linkrel preload. Has anybody used it? Yeah, so use linkrel preload, specify the CSS file. You have to say that this is a style, so as style. And then once it loads, you change the relationship from preload to style sheet. It's that easy. The only problem is right now it works on Blink-based browsers, so on Chrome and Opera. It's coming soon on Firefox, and I think on Safari as well. But for now, if you want to use it everywhere, you have to have a load CSS script and polyfill, which is tiny, so you could also include it in the head. And for JavaScript, you probably want to use async or defer. It depends. If you've got multiple scripts, you can use defer to make sure they have all the same executing order. Or if you've got only one script, you could use then async. And this will make sure your scripts will not block the page rendering. And when you don't block the page rendering, you will have something on the screen as soon as possible. Another pattern that we typically use on the web is called the app shell. Has anybody used the app shell? Maybe a lot of you use the app shell, but sometimes the name is not that common. It's just the minimal HTML, CSS, and sometimes the JavaScript that you need to power the user interface. So let's take an example. If you open a native app like Facebook, you will see the app shell immediately. You will see the nav bar. You will see maybe some, you'll see the sidebar and maybe the container here, but you won't see any content. So this is the app shell. This is the most important piece of HTML, CSS, and JavaScript that powers the user interface. And then once you have the content will just populate in the view dynamically. The reason why we do the app shell is because the app shell is static, and you can serve this in less than 300 milliseconds. So you serve the app shell, and once you query your API to get the content, you'll just put them inside the app shell. So how can we do the app shell on the web? It's actually very easy. You can merge this idea with the critical CSS in the head. If you want to do this app shell, for example, you just inline the CSS for it in the head. Because this CSS is blocking, and this is the first piece of code that the browser is going to see. So you'll make sure this is prioritized for rendering, and you're not wasting bandwidth, you're not wasting time to go to the network to get this. So, and I want to show you here, it's not a magical CSS, that you can do an app shell in less than 50 lines of CSS. But what I also want you to focus on as well is the app shell is about critical code prioritization. You thought that, let's go back here. You thought that this piece of HTML is the most important one, so you prioritized it. You also did the same for CSS. But I also want you to think about JavaScript, because sometimes you've got like a burger menu that you can see on top of the fold, but if you click on it, it doesn't do anything. That's because the bit of JavaScript for this element was not prioritized. You had to wait maybe 20 seconds or 30 seconds for this JavaScript to run. So make sure to always think about prioritizing critical HTML, CSS, and also JavaScript. The next tip is service worker is progressive web app dependent. It's only for service workers, but it will also help you understand how the browser renders the page. So it's important to delay service worker registration. Let me show you why. On a first visit, when a user first comes to your website, you don't have a service worker installed. There's no way you can have a service worker installing your page because this is the first visit. So we can only do a couple of things to make it fast. We can rely on optimizing first paint, which we talked about. We can also rely on having an app shell to have something on the screen as fast as possible. For subsequent requests, if there's browser support for service worker, then you will have a service worker running on your page. So you can show the content as fast as possible. So let me show you what happens if you do early registration. So if you use the snippet of code that I used in the beginning, so if service worker and navigator, and then you immediately register, you see we're wasting CPU and bandwidth to register the service worker, which is delaying the first paint, which is delaying the first time experience for the user. So instead of focusing all the resources, all the CPU on serving all the CSS, the index.html, and the app.javascript, we're actually wasting resources to install a service worker. And this will make it slower for the page. So what I recommend instead is to only register the service worker once the page has loaded. So you could simply change it to add an event listener on load, and once your page is loaded, you can then register the service worker. And you can clearly see the difference here. This is how we're prioritizing the first paint, we're prioritizing the first experience, and then after everything has loaded, we then request to install the service worker in the background when there's idle time. So that's very important. But of course, most of us are using frameworks, and if you do this approach, you're probably going to slow down your framework because your framework is running on load. So if you have a framework, make sure to run the service worker only after your framework has fully booted. Debugging is also a very important aspect because we all develop web apps, but we need to know what's going on, if they're slow, if they're not, if they're considered progressive web apps, if we have performance issues or maybe security issues. And debugging has become very important. And we have amazing tools, actually. In Chrome DevTools, if you go to the new application tab, you can inspect the manifest. This allows you to make sure you have all the required properties without really having to use your phone every single time you change a manifest. That's nice to make sure the logo is working, or the theme color, background color, etc. You can also inspect service workers. There are a lot of features here. You can see which service worker file is installed. You can also force update it. You can send a test push notification. This is amazing. I don't think this is possible on native apps. I'm not sure, but this makes it very convenient to work with push notifications. You can also send a test sync event. You can also completely bypass service worker if you're working locally. And you can also trigger the offline state because we want to work more with offline because this is not a rare scenario. This is not an edge case. Offline happens a lot. And the best tool available right now to audit your web apps is called Lighthouse. Has anybody used it before? This is seriously one of the best apps. It's a Chrome extension, first of all, that gives you progressive web apps, performance, accessibility, and best practice metrics for your app. So you just run it, and they give you a score and recommendations, what you need to fix, what you need to work on. So this is like having the smartest person that works in a browser, but just right next to you. And it's also available as a node module. So you can, if you're doing continuous deployment, continuous integration, you can also have performance regressions by using the node module. And as of the recent version of Chrome, it's amazing to see that Lighthouse is now available as part of DevTools. So you don't need to install the Chrome extension. You can just right-click, inspect element, go to audits, and perform an audit. Even if you're not building progressive web apps, I recommend that you use Lighthouse because the performance, accessibility, and best practice metrics are amazing. So now let's talk about home screen considerations. Assuming you built a progressive web app, or even if you don't, but if you have an icon on the home screen, your users expect it to be fast. Most users don't even know there's a term called progressive web apps. They don't even care. But if they have something on the home screen, they expect it to have native-like performance. We tackled the first problem, which is we don't want them to wait on a white screen because it looks like a web page. And the next one for performance is we don't want to have a slow experience, or we don't want to have something on the screen that we can't interact with. And there's a common question that I see on the internet, like, can I make my website as a PWA? It's like you pass in your website through a generator that makes it a PWA. Technically, yes, you can, but please don't. Because if you have like 2 megabytes of JavaScript and you make it as a progressive web app, it will still be slow. That's a problem. So only try to make progressive web app by improving your performance. And sometimes, unfortunately, it means if you're using old frameworks, you have to start from scratch. But big players already did this. Twitter already did this, and they have now an amazing PWA. It's just mobile.twitter.com. I completely uninstalled the native app, and I'm using the PWA. It's been about 6 months. They started from scratch and started improving performance gradually. So we talked about the app shell. And what comes after the app shell is the first meaningful paint, when you start seeing something useful on the screen. And then afterwards, you've got the ready for interaction. And this is the most important one. A lot of times you have content on the screen, but JavaScript is still loading or is still parsing, so you cannot interact with it. And this is a real trace that I took from my MacBook Pro, but with 5 times CPU throttling, so simulating a high-end mobile device, or you could say low-end. And it takes 8.25 seconds just parsing the JavaScript file. So it could take a lot to parse JavaScript file. So what can we do about it? First of all, I recommend that you use Source Map Explorer or a similar Webpack plugin. This is not based on Webpack, but this allows you to see what kind of JavaScript you're shipping. And you're most likely shipping things that you don't want. You may be shipping an entire Lodash library, whereas you only need a couple of functions. You may be shipping some testing tools by mistake. You may be shipping 2 versions of the same libraries. And there's no way for you to know about this other than going through Source Map Explorer or equivalent tools. Another important thing to do is to use code splitting. I cannot stress how this is important because let's say theoretically you're not using any framework at all. So you're building using whatever technology, there's no overhead at all, 0. Eventually, after a couple of months, your JavaScript is going to reach 1 megabyte. And once you reach 1 megabyte, there's no way for this to run fast on mobile. There's absolutely no way, even if you're using Service Worker. So what you should do instead, you should be only shipping the JavaScript that you need for every single page. So if I go to the index.html, you should only ship the common bundle, the part of the JavaScript that's used in your entire app, and only the JavaScript that's responsible to serve the index.html. You could improve things and preload the other parts of JavaScript, but the blocking scripts, the most important ones, should be only for the index.html. There's no point in serving, for example, moment.js or maybe internationalization or the code that powers the settings.javascript if I'm visiting the homepage. That's how we should think about it. And that's the only way to scale our JavaScript performance. There's also an awesome Chrome DevTools feature called live code coverage. Has anybody used it? Yeah, it's amazing. You just go to a website, start recording, interact with it, and it will show you in real time the amount of JavaScript that you're using in green, the amount of JavaScript you're not using in red. And if you go to any website that is not optimized for mobile, like any website that uses jQuery or big libraries, you will see like 80% of JavaScript not being used. Or if you're shipping an entire app.js for your entire website without code splitting, you will see this a lot. You can also use this for CSS. And if you click on a script, you will see exactly which lines are being used and exactly which lines are not being used. It doesn't mean you have to strive for 90%. It's probably too hard to achieve. But if you have like 60, 40, and you have a small number of JavaScript files, then this is a good. I've been also doing a bit of research. I'm not the only one who've done this, but you can check out Promifil. I noticed that a lot of websites have been loading polyfills all the time, and especially for Fetch. Fetch now works on all browsers, except a couple of versions back for Safari. So it doesn't make sense to always load the polyfill. Even if the polyfill is not running, you're still loading about 8 kilobytes of JavaScript. So I've done some research about conditional polyfill loading, and that's how you can use it. You can call the Promifil method, and then give it a test. Is Fetch supported in window? Or you could use it for Intersection Observer, for example. And if it's not supported, you can give it a polyfill. You can give it your own polyfill, so the path to the polyfill. And then this is a promise. Once you resolve it, it guarantees that you have access to Fetch. So you kind of delay all the Fetch requests until Fetch is loaded or is available in the browser. So the benefit of this, instead of blocking all your app.js until the Fetch polyfill is loaded, and sometimes it's not needed, your entire JavaScript continues on running, but only the Fetch dependent code will be delayed, only if necessary. So let me show you how it works in the browser. This is a screenshot from a browser with Fetch support. We've got the index.html, which loads the app.javascript, and then immediately we fetch the users. But in browsers without Fetch support, this is the index, which loads the app.javascript, and then has to block and load the Fetch polyfill before it's able to load the users. So I think this is a good approach, especially for Fetch, because more than 90% of your users have Fetch natively in the browser already. So all of this is me talking about the mobile web from scratch, but most of you are using JavaScript frameworks and libraries. So I've written a couple of things that you should look for when looking for a new framework, if you want to choose a framework. So first of all, you have to make sure the framework has a smaller bundle size, because if you start with a big bundle size, you can't do anything anymore. So if you start with like 200 kilobytes or 300 kilobytes of necessary JavaScript, required JavaScript, you cannot do anything anymore about performance. Another thing is the ability to code split, because if you cannot code split, in a couple of months, you will end up with a big JavaScript file. The third thing, I think it's very important, especially nowadays, is platform leverage. And one example of platform leverage, there's no need to ship a jQuery Ajax-like library or an Ajax-like library because we have fetch. There's no need to ship JavaScript versions of web APIs that we now have in the browser. The only thing you should do is probably conditional polyfill loading in case they were not available. And there's a framework that does conditional polyfill loading, which is Polymer 2. I'm going to talk about it later on. So in case you're using React, you could use the Create React app, which generates, I think, a PWA for you. And even if you're not building a PWA, we're more interested in the performance benefits. So you could disable the web app manifest. You could disable the service worker, although you probably should not disable it. But you will have an optimized boilerplate already. Has anybody used Preact with a P? Preact is a 3 kilobyte alternative to React. And I think this makes it extremely interesting for progressive web apps. Especially Uber and Lyft are building progressive web apps with Preact, because the overhead for the framework itself is only about, let's say, 4.5 kilobytes once you include the router and once you include a compatibility layer. And even though I wasn't a React developer, I suddenly became very interested in it because I can develop single-page apps with just a tiny, tiny overhead. And I think this is amazing. You could also, using Preact command line, you can also generate a PWA out of the box. If you're using Vue, you can also init a new app with the PWA boilerplate as well. If you're using Angular, that's to say Angular versions 2 or above, there's the mobile toolkit, which is being worked. I think it's for version 5, but it's currently disabled, so this doesn't work just yet. It should probably work on version 5. Right now, what you can do is you can build for production with ahead-of-time compilation, and then this doesn't exist as well. You could write it yourself. This is an NPM script where you could possibly run SW precache and SW toolbox and all the things that I talked about in the beginning. And if you're using Polymer 2, you can just Polymer init and then use the starter kit, which gives you progressive web apps and also the purple pattern. The purple pattern is about code splitting and also at the same time preloading other JavaScript files that you may need in the next view. And what's interesting about Polymer is that it's only 11 kilobyte on Chrome and Safari. That's because web components are native on Chrome and Safari. If you use it on Firefox, you need to load a bigger polyfill. If you use it on Internet Explorer, an even bigger polyfill. So that's, again, conditional polyfill loading. That makes Polymer amazing, because most users are on mobile, either Chrome or Safari. So for those users, you do not need to ship more than 11 kilobyte for the framework itself. All right, now let's talk about some upcoming web APIs that make the web even more interesting. So first one is passive event listeners. Has anybody used it? This one is very easy, but typically, I want you to know that if you add a touch event to your page, you're just making it slower, and it's not your fault. This is the way events work in the browser. The reason why it's slow is because it's cancelable. You can cancel it. So let me show you why. So let's say your user touches something on the page. This is going to go to the compositor thread, which is then going to trigger the touch move. And then we call the onTouchMove event that you provided. So this is the callback function that you provided. And let's say this is going to take about 50 milliseconds. After this runs, the compositor thread is finally going to commit it to the GPU. So it takes about 60 milliseconds from the user touch to the commit to the GPU. And during this entire time, scrolling is blocked. So why can't the browser just immediately commit it to the GPU? Because you can cancel the event. Because you could run event.prevent default. So here in the touch move, you could decide not to commit it to the GPU by running event.prevent default. So that's why the browser has to go through all of this before it commits it to the GPU. So that's not your fault. That's a problem. That's a design problem. And the way to solve it in all browsers, it's probably coming soon to other browsers as well, is by just specifying the third argument as JSON object passive true. And that's a way to tell the browser, this is a passive event listener. I'm not going to call event.prevent default. And this allows the browser to short circuit the entire thing and directly commit it to the GPU. Now, of course, if you call event prevent default, it's simply going to be ignored. So let me show you how dramatic it is. On the left, you'll see an unmodified website, and on the right, you'll see how fast it becomes. So I don't know if you noticed, though, it's been a while we haven't had slow scrolling on Chrome on mobile. The reason behind it is Chrome 56 started making most touch events passive by default. But I still want you to know about passive event listeners because you want to make fast experiences for Safari, Firefox, and other browsers. So it's good to use it, even though Chrome is doing it by default. And this is only the case for touch events and wheel events. So don't use passive events if you have a click handler or update or anything else. Another web API is very important because it allows us to defer non-essential work. So this is called request idle callback, and you can give it a callback. And this callback allows you to run small pieces of work when the browser is idle. And this typically happens right before the visual sync on the browser, right before the browser is going to draw a screen on the page. And the browser is only going to give you small chunks of work because you want to make sure you don't exceed those, because you want to still have frames that run every 16 milliseconds or every 60 frames per second. So this works on Chrome, Firefox, and Opera at the moment. My favorite one is called Intersection Observer. Has anybody used it? Intersection Observer is supported on these 3 platforms right now. It's a way, but Firefox support is coming very soon. It's a way to ask the browser about a visibility of a certain element. And this allows us to do a lot of things. So this is the element. I want to know how much of it is visible. And you also get an intersection ratio. So here's how it works. You define a new intersection observer, and you get back entries. In my scenario, I only have, let's say, 1 div, so I'm only interested in the first entry. And then you get a property is intersecting, which is either true or false. And then you could know if this element is visible or not. You could also do more advanced things. You can also get the intersection ratio. And then finally, using this intersection observer, you have to observe an element on the page. So you may think this is not a big deal, but this allows us to do a lot of things on the web. One use case of this is infinite scrolling. You could do it in a much more performant way. You could also lazy load images. So if you go on Tumblr, for example, if you scroll down a little bit, the entire page is extremely slow. That's because they probably load all the images, all the videos ahead of time or immediately. Whereas if you can lazy load some of the videos, you can only load them once they're in the viewport and maybe hide them later on once they're outside the viewport. Also, ad libraries later on will be able to do advertisement visibility in a much more performant way. So this is something that ad libraries will be using, hopefully when we have better browser support. You can also do more advanced things, like if you have a video that's playing, you can have a mute button that only shows up once the video is outside the viewport, and then hide it once it's inside the viewport. You just have to know that this is not suitable for scroll-dependent animations. I never tried to do parallax. I don't think you should do parallax anyway. But this is only for things that are not really scroll-dependent or like low latency, extremely low latency. Another interesting feature is background sync. There are 2 sub-features in this one. The first one already works on Chrome. It's been a couple of months already. And this one allows you to send something to the network. And if there isn't any internet, then it waits for connectivity, and it employs an exponential backoff. So it's first going to wait for 1 second, then 2 seconds, and then it grows exponentially. So if you're building a chat application, you could let your users send a message, close your app, close Chrome, and once they have internet, your message will be sent. But the only downside is that it only works on Chrome at the moment. There's also another feature of it, which is called periodic sync, which doesn't work anywhere because it's currently being spec'd. So this might change a lot. This allows you to pull some information from the internet, say every 5 minutes. And you don't have to specify these two, but you could be more specific. You could say, only do this on Wi-Fi, so avoid draining, and avoid cellular, and only do this when the phone is plugged, avoid draining. There's also CSS containment, and I think this is a great one, especially for web components, when used with web components, because typically if you change the width of an element or the left property, then the browser has to do layout for the entire page. And in some scenarios, this could take as long as 60 milliseconds. Whereas if you specify contain layout for an element or for a web component, then you would contain the entire layout to that element. So the browser does not have to go to the root. It will only do the layout for this particular element. And this basically makes reflow much faster on your page. Another very interesting feature is called the payment request API. This is not a payment provider. This is only a payment modal, a native payment modal that uses the autocomplete for the user's credit cards and addresses. So if you're using Braintree, PayPal, you could still use them and configure it. It's just a super fast way to buy something on the internet. You click on a button, it already has your address, credit card, you click pay. This allows you to do pay. You can also do buy one item rather than having to add to cart, create an account, etc. You could do like a quick buy workflow. This works on Edge on all platforms, even on desktop, and it works on Chrome on Android right now, and it's coming on desktop for Chrome 61, all platforms. I think Linux, Mac, and Windows as well. There's also the Web Share API, which doesn't work anywhere at the moment. It used to work on Chrome, I'll tell you why. And it's a way to trigger the native sharing modal, a native sharing window from the browser by just calling navigator.share. You give it a title, a text, and a URL, and it's going to open the native share. And you could choose, I want to share this to WhatsApp or to Facebook or to Twitter. Has anybody heard about origin trials? OK, so let me tell you more about it. Previously, we used to have -webkit, -moz, etc. All of these vendor prefixes, which kind of ruined the web. The reason why those features existed because the feature wasn't stable enough, but then all of us started using it to a point where you had Internet Explorer had to accept WebKit properties or else web pages would break. And this was a big problem. So origin trials allow us to do experimentation on the web, but in a safe way. So the WebShare API used to work for about 6 months, but you had to specifically sign up for it. And you had to put a meta tag in the head. And this feature was not always available. So in that way, you as a web developer, you had to always check if the navigator share method is available before using it. So there's no way later on, if the spec change, that the browser will say, oh, we really have to keep that old version because there are so many websites using it. So it's a way to do safe experimentation. Plus, the feature will automatically self-destruct once it reaches a certain threshold of users. So say if more than 0.5% of the users in the entire world are using it, then the feature will automatically self-destruct. And that's a good guarantee. Imagine that Facebook rolls out WebShare, and then you have like 30% of the entire world using it, and then the browsers say, oh, we have to keep this old version. So this was being experimented for about 6 months, and I heard there was some very, very good feedback, so hopefully we should see it soon in browsers. There's also improved add to home screen. This feature is specific for progressive web apps and Chrome for Android, but this is how the improved add to home screen flow will look like. Once you add to home screen, I'm using Chrome beta here with a couple of flags enabled. It will take a while because it's in beta. But once this is installed, you will see now the real difference. You have the home screen icon, but that's not really an icon anymore because you could uninstall it. You can find it in the app drawer. You can search for it. You can inspect it. So this is a real app. It's using web APKs. So this is the future of web apps, the future of progressive web apps, where you will have, once you add the progressive web app, it becomes a real app on your screen. So you can have it, you can remove it from the home screen, you can keep it in the apps drawer, inspect it, see how much battery it's using. And this is very amazing, very, very awesome. But it doesn't work right now. It's only on Chrome beta with the improved add to home screen flag enabled. We also started to see PWAs on desktop. The first one was Chrome OS. You get an add to shelf, just like you get add to home screen. And if you add to shelf, you will get the Chrome website, but without the Chrome UI. Just like you would do on Android, but you will have the same on Chrome OS. Windows 10 is also working on the same with Edge. And the Windows Store, they announced at the Build conference that they started indexing progressive web apps. So the Windows Store will have progressive web apps there as well. So you can search for them. You can also install them. And if you install them, they will be super fast because you're typically just installing an index.html. It's not like you're installing 30 megabytes or for an app. How many of you have heard about WebAssembly? Okay, a lot. So WebAssembly, that's a cross-browser, low-level language. It's supported on all browsers. Some of them are behind the flag, but the minimum viable product is out there. Already some websites are using it. This is an example of a WebAssembly. It's very tiny. This is a sample method that just adds 2 integers at the moment. So let me show you how you can use it. It's a bit clumsy to use it. I'm using async await functions. But later on, this will become much easier, especially Webpack. Webpack just received funding in order to make loading WebAssembly as easy as importing. So once you do all of this, once you fetch the file, convert it to an array buffer, create a module, instantiate it, etc., if you console log what you get back, you'll get back a native add-to method in your browser. And this allows you to run native code in near native performance. It's going to become better and better as we go forward from your JavaScript file. And what this basically means, why this is amazing, this is your web app or your progressive web app, and this is WebAssembly. And now there's a bridge between them. So we could do things that we never thought were possible on the web, like image and video editing. Already Figma, which is a Sketch-like or Photoshop-like editor, is using WebAssembly on the web for their image editing software. You can also do image recognition, encryption. A lot of things will become possible because of WebAssembly. So I hope I got you excited about the future of the web. I have a call to action for you. If you go to speedtest.net right now, they will probably tell you, thank you for coming to our website, but we don't know how to build a good website, so please download our app. And I don't think it makes sense a lot. You may have to do this in some scenarios, but in most scenarios, you don't have to do this. It doesn't make sense to download 30 megabytes on Android and probably 200 megabytes on iOS to do a speed test. You're probably on the go. Megabytes cost a lot of money, and you don't want to keep storage space for an app because you just want to run a speed test. Also the same for Reddit. If you go to Reddit, they will bug you 30 times, like download the app, download the app. They even have an option where you can disable it. I don't know why they complicate it a lot. We can do amazing experiences on the web already, so make sure to benefit from this. So make sure to build your first modern web app or PWA. So if you're already working on a legacy app, start a side project and start by getting rid of your entire business logic and build something from scratch. When you build it from scratch, you will understand how the modern web works. And I think it's very important. And then after you've built something from scratch, you could then integrate your business model or business logic. And then later on, if you want to use a framework, you could start from scratch again using this framework, but with better knowledge or better understanding of the underlying platform. Also, make sure to always have your phone next to you. If you have an Android, make sure to plug it and use Chrome. If you have an iOS, make sure to use Safari. They have DevTools, and plug it in. Because what takes a fraction of a second on your MacBook could take up to 5 seconds on a real mobile device. So you want to always make sure to test on a real mobile device. And when you're not on mobile, make sure to use throttling features. So I typically go down to regular 3G. In the new Chrome, these are slow 3G and fast 3G. Also, make sure to use CPU throttling, 5 times or 2 times CPU throttling. And check out these amazing PWAs. First of all, you can go to twitter.com, and you'll see their progressive web app. It's probably less than 1 megabyte, or say 1 megabyte tops. On Android, it's about 40 megs. On an iOS, I think it's 150 megs. So it's amazing the difference of sizes, and just because we're using different technologies. Also, Uber has released a progressive web app that's using Preact, code splitting as well, and preloading. And this is amazing because they have like 40 different JavaScript files, but they only load them once they're needed. You can also check out Wigo, which is built in Polymer or Polymer 2, and Flipkart, which is built in React. I've used Google Web Fundamentals a lot and Mozilla Developer Network throughout my talk. If you want to get more insights about progressive web apps and modern web APIs, make sure to check them out. And you can find my slides online on this talk and my Udemy course on how to become a better developer on this link. I hope you enjoyed this talk. We have 13 more minutes for questions. Thank you. Yes, we have a mic. Yeah.
Well, first of all, thank you so much for the wonderful talk. Now, I just have two quick questions. So first question is about with server technologies, the real challenge on the client side is how quickly technologies change. And you summed it really well, it started off with basic HTML apps back in the day, and it then moved to things like web frameworks like React and Angular, and now it's moving towards web components and also towards PWA. So isn't this a challenge for big companies, how they continuously evolve their products, and what do you think can be done to sort of better improve that experience? And the only other question I have is you focused a lot on PWAs, and while PWAs are really good for mobile applications, but the stats on the internet say 75% of internet users in the United States are still desktop users. So do you think a PWA app works well for desktop devices? Just two questions.
Okay. So the first question was what can big companies do about the fact that the web changes a lot? Yeah. Okay. So I think I would use the example for Twitter, because Twitter had a horrible web app which was using jQuery and a lot of jQuery plugins. It just take like 20 seconds to load. And then they built a new one from scratch. And the new one from scratch they built was actually very slow as well. But then they started improving it step by step. I think there's one thing that really helps you with this, which is focusing on only one business metric. Like for Uber, it's about only requesting a ride. If you're doing too many things, then it becomes very tough. I don't think anybody has built a PWA that does so many things right now. And I don't think it's good for UX anyway. So maybe just focusing on one important aspect, just like Uber focuses on getting you a ride in less than 200 kilobytes of JavaScript, is very important.
But what about enterprise web applications, like a very big website, like maybe not Google, but like an enterprise CMS? You won't do a PWA for it, right?
Well, depends. You don't always have to do a PWA, but the reason why I talked about them, because they always push towards best practices. You could take maybe only the best practices that make sense for this enterprise company. And for the second question, it was, what was it? About desktop, yes.
Yeah, so it's like, it's like if you are using a PWA, because like you said, Angular is going to introduce PWA support in NG5, and React is already doing it. Yeah. So let's just say, like with my company, our target audience is an enterprise audience. So if we choose to PWA enable it, do you think we're going to get any benefit? I think you already answered it. It's best practices, is it?
I'll tell you something. Have you ever used Google Inbox? Google Inbox, which is the new version of, it's already using service workers, and that's why it's amazing. If you're on the plane, you could read previous emails, you could add reminders, and this makes it already, even on desktop, yeah, even on desktop. So I think there's a lot of benefits for it as well. Sure. Any other questions? All right, then you can find me after the talk if you've got more questions. Thank you.